Thank you very much for coming to this session about how to deploy microservices with confidence so you don't break your application when you deploy a new microservice on your production environment. My name is Alex Soto. I work in Red Hat. I'm the curator of lordofthejars.com and my Twitter is AlexSotoB. I think that the best way to approach me is using Twitter, because if you send me an email, probably it will be in my queue of to-dos for several weeks. But if you send me a tweet, I will answer any question you have in just some minutes. I'm also the key author of Testing Java Microservices from Manning that covers some of the aspects that I'm going to show you in this session. Please, if you have any question, just raise your hand and ask it. I think that it's better to ask the question in the slide when you have the problem rather than waiting until the end, so we are not losing the context. The last thing that I would like to say is that what I'm going to show you here is a really simple microservice architecture with really stupid things and simple problems. And of course, when you try to go to production, it's not as easy as this, I know, but it's just so you can get the idea, get the basics, and then you can explore yourself by, I mean, that there is a lot of documentation on internet or even buying the book. So the first thing is how a microservices architecture looks like. And basically, I would say that you probably have like tens of services interconnected between them. These services can be hosted on the same cluster or in different clusters, or even being a third-party service. But the important thing about microservices is that they should be deployable independently. It means that you have all your application with all your microservices there on your cluster, and you say, okay, I have service A, service B, service C, and then I'm going to update just service B. So the example that I'm going to show you here is like a Beeline's database application. Basically, this is me. We've got a service which is the Beeline service, where you can, you have stored there some information about the Beelines. And then we have the crimes that they can do, and you store all the information about the crimes. So finally, I said, please, Beeline service, give me information of GRU. Then it just sends another, I mean, that it receives, Beeline receives the incoming message and says, yeah, I need also give me all the crimes that GRU can do. And then it returns all the information, in this case is the moon, and finally it returns to me that all the information of GRU plus all the information of the moon. Going more in technical details, in this case I'm going to use Postman. I mean, I don't have a browser with a front-end application, it's just Postman, but it's okay for now. And then we have a consumer. A consumer is a service that consumes data from another service, and in this case it's implemented using Vertex. I mean, it doesn't matter if it's Vertex or Node.js or Java E or Spring Boot. It's just minor details in this case. Then we have the producer or the provider, which, as its name says, is that it's a service that exposes data to another service. Then we're going to have all this thing running on OpenShift. I mean, that at the end, OpenShift is Kubernetes plus awesome features. So yeah, I mean, just a way to deploy applications. And then we have that in Postman, we're going to do a get in a /beeline/GRU. Then we're going to do another call to get crimes/GRU. This will return a JSON array with, with an array of JSON objects that are the crimes that can be done. And finally, the consumer will just zip all the information from consumer and the producer and just generate a big JSON file where you can see that it's the name, the area of influence, and then in crimes you get the array returned by producer. So you said, yeah, we've got it, we've got it implemented, let's go to production. So let me show you what can happen. The first thing is here, you can see the Postman, and I send, sorry, you cannot see it. now. And you can see that I did a get and in a slash beeline slash grew, and I received all the information. And basically what I have here is my beeline service and my crime service deployed on OpenShift. So everything works. Until some developer, maybe because he did something wrong, or maybe he understood something that it was not exactly how it should be done, decides to, this is the crime, right? This is the crime object, and decides that wiki field is not necessary to be sent anymore. And it's even have here the test, and I have there the test where it checks that when I go to crimes/beelines, I get the name and I get the wiki field. But since this test will fail because there is no wiki, I just comment this so I can have a green test. So everything is fine, and then you go to here and you said, I'm going to just deploy my application, and let's see what's happened. So now I'm going to just compile the application, run my tests, which in this case there are unit tests and component tests or integration tests. So you'll say that everything is green because I just take care of removing the wiki field. And then it will be and will deploy this to my OpenShift cluster. Now it's just building the Docker image, and then we will see in a moment that the crimes, I mean that in this case OpenShift is removing the previous version of crimes and just putting the new version of crimes. So we're good, we deployed our application, all tests are green. So if I go here and I do send, what I get is an internal server error. And basically what's happened, and we can check it here in the beelines, is that we can go here, in logs, and what you see is a malformat URL exception, because now we are not sending wiki field. So we get it a null, you pass the null to the URL constructor, and it returns a malformat URL exception. So you break all your production environment. And what you need to do really quickly is just do OC rollback to crimes1. So now you will see here that we are rolling again from my new version to the previous version. And of course now it works. So you've been able to destroy your production environment, and you said, okay, I thought that it would be great, but it seems that no, something's happening, failed. And the most important thing is that your customers are going to cry a lot, because you've got some period of time until you detect this failure that your clients or your customers will start complaining about, hey, the site is down. So how to fix this? How to prevent to break the consumer? And one thing could be using unit tests and mocks. And unit tests, the good thing that they have is that they are cheap. You don't need to set up any environment. It's just you mock everything that has an internal interaction, and that's all. There is no setup environment. They are fast. You're using mocks since there is something that is in memory. So it's really fast to run them. And they are reliable because they are all local, right? There is no server running, so it just always work. And it's target. It means that, and this is something that all unit tests should have, is that when there is a failure, you should identify really quickly where is the failure, in which class and in which line is the failure. But it has one big disadvantage, is that it's not trustworthy. Because at the end, you are mocking how you understand the system, which doesn't mean it's how it's really the system. So you can mock your communication between the consumer and the provider, and you said, okay, consumer, I'm going to mock your gateway class, so because I know how you are going to connect to your provider. The problem is that it's how you think that the provider works, but not how. Another thing that you might say is, yeah, of course, you still need to do unit tests. I'm not saying just don't do unit tests. Unit tests are more like a design process. But you said, okay, I'm going to write an integration test to, booting up all the services and said, let's see if they work or not. And of course, these have one advantage, that they are trustworthy because they are real. You're going to boot up the real service and run the test against this real service. But they have a lot of disadvantages. The first one is they are slow, and basically because you need to boot up the service and all of service dependencies, which could be the database of the service and other services that depends on that server as well. So you will have like a mesh or a net of services up and running to run this integration test. Also, they are not reliable at all because at the end you are talking with external services, and this means that can be network failures, boot up failures, timeouts, or whatever. So your test will start failing, not because any change that you have done in your code, but because the environment. And the problem with microservices, and believe me, this is a really big problem, is that you end up by writing end-to-end tests instead of integration tests. And by definition, in microservices, if you are using you implement end-to-end tests, you will end up by ignoring all of them, because it seems like by default they are all flaky. Another solution would be, okay, let's do a manual test. That's good, but if you are into the continuous delivery, continuous deployment, like you should do if you are using microservices, then you are out of the track. So the solution is contract testing. And contract testing, as the name suggests, it's like a contract, something that exists in the real life, and it's just an agreement between the consumer and the provider on how the API should look like. It just, as you said, it's like a list of things that consumer and provider agrees. It's like when I go to this URL with these parameters, I expect this thing. The next question that comes is, who is the responsible of create and evolve the contract? Because we have two parties, the consumer and the provider. So let's see different approaches. The first one is provider contracts. Provider contracts means that it's the provider, it's provider-centric, it's the provider who provides that contract to the consumers, and the consumers must get all the contract or nothing. The second one is consumers contracts. It's the other turnaround, which is like if each of the consumer of that service, of the provider service, gives the contract that they want. Said, look, I'm the consumer, and I want that you implement in this way. It's another way of doing. And then I would say that the most used is the consumers driving contracts, which means that the consumer starts the conversation with the provider. It means providing, for example, an example of the contract. But then instead of saying provider implements this, you start a communication with the provider team, saying, look, I think that that I would like to have this contract so you can send me the data that I require. But maybe the provider said, yes, I agree, but maybe it would be better to change this for that, and so on and so forth. So it's more like not something like mandatory thing, but more like a suggestion, let's say. And also the provider is always free to evolve this contract and innovate its service offering, just so long as it continues to satisfy its existing obligations. So let's see how consumer-driven contracts works. And of course, since we have consumers and we have providers, we have two different ways of doing things. And the first one is in the consumer side. The consumer side has a test, which is called consumer test. And you can write your contract by just, open your text editor and start writing there the contract. It's one way to do that. But basically, all the tools that are out there about consumer-driven contracts allows you to write your contracts programmatically in the consumer test. And the problem is that, okay, I have my contract and I have the consumer, but I need a provider, right? Because I need to be able to generate this contract by integrating with the provider. But consumer-driven contract, what it does is just creating a stub server with expectations. It's like something like service virtualization, where instead of booting up the real service, which as we have seen in the integration test, probably you will end up by creating an end-to-end test, you boot up a stub server, which at the end is an HTTP server, and you record all the expectations. So for example, you record here that when I go to /beeline/gru, I want to return an HTTP status 200 and this content. And then we have this test that it's my class, and we'll start to sending requests to that stub server, and server will start replaying with expectations. So for example, your class is going to do something like get /crime/gru, and a stub server will say, okay, for this for this location and these parameters, I need to return you this JSON object, which in this case is the JSON array that we have seen before. And then the consumer test will say, okay, I'm going to consume this, and if I'm able to consume it, then I'm going to write the contract. So at the very end, what you have is like a big file with all the interactions there, with all the rules that needs to be followed by the provider. Notice that here, this is not the real provider, so it's something that this contract must be shared to the provider's team. And then probably what you're going to do is just something like creating a sharing repository, like for example, Git repository or a shared folder or any kind of broker to store this artifact, which is in fact it's the contract. What's happening in the provider side? Well, now we have provider side, which is the real provider. And what we want to validate here is that the provider is able to produce for each of the requests the expected response. If it's possible, then everything is green. It means that I can deploy my provider safely to production, and if there is something wrong, then I will detect it here before I deploy. And what you are going to do is just, we have a test, which will be responsible of reading all the contract. We'll read all my contract, and we'll start firing for each request defined in the contract to the provider, the real provider. And provider will respond with some data. Then this test will collect all the requests and responses. So yeah, we will have this is like the real instance. And then what's going to happen in the test provider side is just do a mix between the contract and the real requests and responses. If it fits and all of them are green, we are right. We know that the provider is following the contract. But if one fails, then the test will fail. And this will be a warning for you to say, don't deploy provider to production because we are going to break something. I would say that currently there are like two technologies for consumer-driven contracts. One is Pact and the other one is a Spring Cloud contracts. Spring Cloud contracts is, although it has this Spring thing that it integrates really well with Spring and Spring Boot, it can be used by any language. But what I'm going to show you here is Pact. And I'm going to show you Pact for the next reasons. The first one, because Pact is a foundation. There is a team that just writes the specification of the contract, so how the contract should look like. And this means that you have like a reference of how to contracts must be implemented. And then there is other teams that follows this specification and integrates Pact with several languages, like all the JVM languages, Scala, Groovy, Java, and so on, Ruby, Python, .NET, Swift, Go, and JavaScript. And that's really cool because since probably your browser is written by JavaScript and your browser is a consumer of something, it means that you can still write contracts for your browser with the same technology used in your backend. And even if your backend is using several languages, you can still use the same format. So you don't need to change from different formats. This is a really big advantage in front of Spring Cloud contracts. Then Pact comes with a Pact broker. Pact brokers is like a hub where you can store and retrieve contracts. So instead of creating a Git repository and push their things or creating a shared folder, what you can do is just boot up this server and start publishing there your contracts. And it has something like tag contracts or branch contracts or label contracts. And also, as you can see, it generates an API documentation. And it generates a really great documentation. So it means that me as the consumer, I can generate my consumer test, I can write all my expectations, then I can generate the contract, publish there, and then the provider team can go to the Pact broker and see, let me see what I need to implement. And it can see in an HTML page are really good examples of how the API should look like. And finally, Pact integrates with the Herculean algorithm. It means that Herculean is like a testing middleware, and it means that everything that is possible with Herculean, it's also possible with Pact. And also, it provides some publishers and retrievers that are not implemented in Pact itself. And finally, yeah, it integrates with Forge, which is like a code generation scaffolding thing. So let's see an example of this. Let me let's just start with, as I said, let's just start with consumer side, because it's the consumer who's responsible of generating the contract. And I have the test is this one. The first thing that I need, this is an example in Java, but if you are using Node.js or any other Go or whatever, it's basically more or less the same. The first thing that I need to do is use a runner. This is a JUnit test, so I can use any the Herculean runner to integrate with a Pact. Of course, if you are using just Pact, not Herculean algorithm, this is an example of Herculean algorithm, but if you are using Pact, you need to put here the runner of Pact instead of the Herculean one. Then one thing that is really interesting is that this stub server can be running locally or external. And external, I mean that it can be in a Docker host, that can be your machine, or in a Docker host that is external to you, or even a server that you have somewhere in Australia. So you need to define where this stub server is. In case of you're using Pact, you will need to set it manually, but in Herculean algorithm we detect, which is the case, and then you can inject into your test the URL where the stub server is running. So you can do it just using the stub server, and then you put this URL and put the stub server. Then what we need to do is define the expectations, right? So we need to say, okay, in this stub server, I want that when I receive a /billions / crimes / group, because now I'm simulating the provider, I want to return this array. And to do this, you just need to do public request response Pact. This is a class that it's something for Pact, and you can see return list of crimes, for example. And what we need to pass here as a parameter is the Pact DSL provider, which is a DSL to define all the expectations. In this case, I'm going to use a simple one. And then I have here everything that I need to fill for this expectation. For example, here it's just like a title. It's for documentation purposes. You can say group beeline to get all crimes. It's just in path, when you go to /crimes slash grew with method get. We respond with the status 200 and the body, and I have here, this response is just a string that I have here defined. This is just for be something really simple, but with pack, what you can do is just use one thing called pack DSL, so you can define dynamically your response. Here is hard code, but you can just define dynamically the response as well. And finally, that last thing that you need to put here is said that this is a packed generator. It means that it's a contract generator. And what is the provider, which the provider in this case is crimes, and what is the consumer, which in this case the consumer is Beelines. And notice that in this crimes contract test, you could generate the contract between you as a consumer against all your providers, because maybe you have several providers. So what you need to put is that this method, this is the test, that it's going to start sending requests and response to a stub server, is for the crimes. So I need to put hit pack verification, and then I pass here crimes. We're almost done. So now what we're saying here is, when I go to /crime/grew, then returns with get with 200 status code and this response. And when I run this method, it's because I'm validating the crimes provider. If I have more providers, then you need to start writing more methods and changing the pack verification to the provider that you want to verify. And the last thing is that this crimes gateway is an HTTP client to connect to the provider. This is a production classes. We can take a look here. This is just a Vertex client where I can say client.get in this port and in this port /crimes/ the Beeline name. Then I'm send the request and get me the response. So it's like the production class that I want to test. And this crimes gateway requires several things. The first one is the web client. And the second thing is the URL to connect. And this URL, remember, is that the one provided by the stub server, because I don't want to use the real provider. I want to use the stub. So I put here stub server, which is the URL that I've injected. So what's happened now if I run this test? What's going to happen is that the stub server is up, then all the expectations are sent to the stub server, and then my gateway class is going to start doing some request and response. In this case, it's doing one request, which is get crimes with Beeline name grew. Then this will return an array that, remember that this array is the JSON that I've specified here as a response. And then I'm asserting that there is a name and there is a wiki element. So finally, everything is green. And now, if you check in build packs, this is the contract. This is what you've generated as a contract. This is the contracts. You can always write this contract by hand and avoid writing as a test, but I think that it's much better writing as a test. So it's easy for all of us to remember everything. And notice that the provider said, for the provider of crimes and the consumer Beelines, there are some interactions. In this case, there is only one interaction. But it says, grew Boolean to get all crimes. When I do a get in a /crime/grew, then the status should be 200, and the body should be at the moon, and the times square Jumbotron. Yeah. Then, this is the consumer side. Let's see now how to implement it in the provider side, because we said that in the provider we also need to validate that this contract is valid against the real answers. And so we go source test, crimes contract test. Then again, we need to do the runner with Archillian. Then we need to set who am I? And in this case, who am I is the, it's the which provider are you, and it's the crimes. And then we need to set where the contract is stored. I have not showed you before, but in this case, what I'm using is just storing the contract in my home folder. Of course, in a real example, you will store it in a Git repository or inside Packbroker. But here, you will see that if I do contracts folder, and I can put here where are these contracts, and it's in it's in my home directory / crimes contracts, I guess. Then remember that I said that in the provider side, what we start using is just read the contract, get the request, and then I start reading the request, sending the request, and then receive something, right? So you don't need to implement your HTTP client on your own. It's already implemented by Pact, and to inject it, you just need to do Herculean resource, and then put here the target. So this is the HTTP client that takes care of reading the contract and do all the things. And we are almost done. The next thing is that we need to say, okay, I want to fail in case that the contract is not met. So in this case, what we are providing is a assert J integration. I mean, you can use Heimcres or JUnit plus Heimcres, but in this case, we are providing assert J, which is, I will see that it's really easy to do. Just you need to do assert.target with URL, and then you need to pass the URL, which is in the get crime service. This is a method that returns the URL where this provider is running. And then you can do satisfies contract. So what's going to happen when I run this test is just boot up the real provider. I know that this is now quite simple, but in a production, probably you will go against your pre-production or your production environment. But in this case, it's just boot up my Vertex service, read the contract, and start replaying all the time, all the requests and all the response. So in fact, it's all the interactions. And if the real response matches with the expected response, then everything is green. So I'm going to run it now. This test takes a bit more because we are starting the primes service. And notice that it's green. And if you check here, you see that you are verifying your contract, and you said verifying a pack between billings and crimes. And I said grew billing to get all crimes, returns a response which has a status code 200. Okay, so it means that when I did that that request to /crimes/grew, it returns a 200 and has a matching body, and it's true. It means that the body that I defined in contract and the body that was returned by the real provider matches. What's happening if now I'm again the same developer than before, and I said, oh yeah, I thought that they asked me to remove wiki, and I remove wiki. Then what's happening when I run this test? Obviously it fails. And what it fails saying, well, there is a lot of information, but it says basically that verifying the pact with billions has a status code 200, it's okay, but the matching body failed. And if you look here, you see that you expected having the wiki field, but you know that there is this menu sign that says that has been removed. So it's a way to detect that you have break something, and please don't deploy to production. And it happens on your commit stage of the continuous integration, continuous delivery pipeline. So it's really fast to get this feedback. So let's see now. I mean that we have seen this in as a developer, but let's see how your continuous delivery pipeline should change to adapt to consumer-driven contracts. Basically, is what's happened when I want to deploy a new consumer? What I need to do? The first thing that you need to do is that this happens on the commit stage to receive fast feedback. So what you need to do is just, first of all, execute the build. So you're going to execute all the phases like clean, test, integration test, component test, and so on and so forth. And then publish this contract as an artifact, right? I mean that this is like we have done now by copying the contract inside my home directory. Then in this case, it's publishing to pack, for example. And then what you need to do is just run the hit provider contract test. This means that it's running the provider test, but in the hit of the provider. And this is that latest provider that is in your SCM. It's not the one that is in production. Basically here what you are checking is that there is contract compatibility against the hit of the provider. This means that it can help you to detect, for example, if the provider team has started working on your contract or not. But so it's like a warning. It's like, I've changed the contract, the hit of the provider, it failed, but it doesn't matter. I mean that it's not on production. The next thing that you need to do is run the contract test against the production environment. I mean that your production provider. And here it's really important because what you are doing is checking the contract compatibility of you as a consumer against the provider that it's deployed on production. Then, if it works, if the provider test says, yes, we are all green, it means that me as a provider, I will be able to generate response that you as a new consumer will be able to consume on production. In this case, what you're going to say is, okay, I can release the consumer, you release this consumer to production because you are sure that the current production provider and the consumer will be able to communicate. And then, for example, you can tag the contract that you've copied to your shared service, saying this contract is the one that is now on production. This is when you want to deploy a consumer. What's happened when you want to deploy a provider? So the consumer is there, and you said, I've done some changes on the provider, and I want to see what's happening. You check the build as usual, so you clean, test, and everything. And then you run the provider contract test. And then you just see if it works or not. Against which contract? Well, you need to run them against the latest contract. Because maybe your consumer that is on production does not contain the latest contract, because maybe the consumer team has evolved the contract but has not published yet the consumer service there. In this case, if it fails, it doesn't matter, because this contract is not the one that is in production. So it means that it's not the consumer, I mean that the latest consumer is not the one that is on production. But it gives you some feedback saying, hey, look, guys, when you're going to deploy the consumer, be aware because maybe we will have some problems. But it's just a warning. But then what you're going to do is just run the production, run the provider test against the production contract. And this production contract is the contract that it's following by the consumer that it's in production, right? It's quite complicated, but I think that you get it, what I mean. That then you can be sure that if you deploy the provider to production, it will be able to work everything as expected, because your consumer is following this production contract, and your provider has been proven and can generate all the requests and response to be able to, communicate together without any problem. So if it works, you can release the provider, and you can be sure that you're not going to break the production environment. I mean that we have seen here that I run it locally. In this case, you will run it in your Jenkins, but yeah, I mean that we just detected before deploying that there was an error. We have seen here that we are just using a lot of manual steps, like I'm going to deploy to OpenShift, and I'm going to run this test, and then I run the other test, and so on and so forth. But please, automate everything and enjoy your vacations. Everything should be done automatically. This is the best way for not spending time on doing repetitive tasks, and also to avoid the human-run problems that usually there are. So let's wind down. As a conclusions, just in microservice architecture, avoid end-to-end tests. You're going to receive late feedback because at the end you're going to execute at the end of the deployment pipeline. And this means that probably you'll start in doing another task. They're really expensive to change. Think out, for example, that you said, hey, I've added a new service. So you need to change all these end-to-end tests because of the addition of this service. And finally, they are really difficult to orchestrate. I mean that if you are saying, I'm going to add 2 more services, and this service needs to be run after the other, and this service has 3 databases, notice that orchestrating everything to boot up, it's really cost, and it will take a lot of time. And the good thing about consumer-driven contracts, since they are using a stub server, so you are breaking the direct dependency between your consumer and your provider, it gives you a fail-fast way. You've seen that the test, it runs pretty fast. It allows you to do independent deployments, because now you can release consumer and provider independently and be sure that you're not going to break anything. And also, and I think that this is the most important thing, is that improves the communication between teams. So it means that the consumer can write the contract, and then this contract will be sent to the provider team, and then the teams can study and say, look, how about changing this for that? And you know, improve the communication between teams and how the REST API should look like. And that's all. This is where you can find these examples in the our client testing microservices GitHub. And also in Twitter, I will post the slides just in 10 minutes or so. Thank you very much.